Okay, today we'll be wrapping up section 6.2, law of cosines. Just a quick recap of what we did on day one. Using law of cosines to solve these two cases. For given three of the sides or an angle in between the two sides, law of cosines is what we use. All right, now just talked about this in the warm-up, but let's discuss this again real quick. Law of sines has like 3 or 4 different cases. It's easier to remember the law of cosines cases. And there's just an easy way to remember it. I should just remember it this way. Remember, law of cosines is for SAS. All right, so if you just kind of commit that to memory, you'll know it's just those two cases. Anything else is going to be law of sines. All right, the nice news is, too, if you forget that, let's just say you use law of cosines, but you should have been using law of sines. So you start plugging things in, and maybe you have 2 unknowns. So maybe you're missing A and C. That should be a hint to you that you use the wrong law. Okay, same thing with law of sines. If you try to set it up and you're supposed to use law of cosines for one of these cases, you'd have 2 unknowns. You'd have to try the other one anyways. Okay, but if you want to be efficient with it, just memorize that, and it gets you right to your correct property. Okay. All right, so we have 2 forms here: the alternative and standard form, one for the angle and one for an unknown side. Okay. All right, so today we're going to work on these applications, these last 2 learning targets. All right, application problems, and then what's called a Heron's formula when given all 3 sides of the triangle. Okay. All right. So find the distance across the lake to the nearest foot using the measurements shown in the figure below. Okay. All right, so they gave us a diagram. Most of the time they do. They're pretty nice to you on this. So they're asking to find this indirect measurement. Obviously, it's tough to take a tape measure or a meter stick or something like that and measure it across bodies of water. So what we do is use indirect measurement and take some readings and then figure out this angle. Okay, so here's our unknown. Just call it X. Again, this is side, angle, side for sure. And we know law of cosines is used for side, 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 and SAS. Okay, and we always start writing this with the angle across from the side. Let me say that again. We start writing this in terms of the side across from the given angle. Okay, so as we saw here in these standard forms, angle A and side A are across from each other. And that's how you start writing it, okay? So I know we call it X, but I could call it A if it helps you out. So we're going to say X squared equals the other 2 sides squared and added together. So 800 squared plus 900 squared minus 2 times the product of those 2 sides, 800, 900, and times the cosine of the angle across from the side that you started writing this with. So cosine 70 degrees, okay? All right, so now we just usually simplify this a little bit before we take the square root, but eventually, we need to solve for X, so we got to take the square root. But I'm going to go ahead and just add these 2 together first. The 800 squared plus 900 squared. So that gives me 1.45 million. Then minus this product here. So 2 times the 800, 1600 times 900. This works out to be 1440000 times cosine 70. Okay, and then we still have X squared. So to get X, we need to take the square root of all of this, both sides. And so we just punch that in. Okay, so 978.5. So the nearest foot, so the 0.5 would take us up to 979. Yeah, Write the applications, as long as we're sure we found the right information or the right unknown side or unknown angle. We're done after one step. We don't have to necessarily solve the triangle and find the other angles. Okay? All right, you guys read 6, try to set it up and find the unknown side. Go ahead. Okay, there's a problem like this in your OTI as well, but they just changed it to a baseball field instead of softball field, and then they changed the direction on it. But and they don't give you the sketch, so this is an important sketch to kind of look at and reference when you try this, because when you draw this triangle right here, you can assume it's a right angle. Okay, so you can assume that it was cut in half, and that's 45 degrees. So keep that in mind when you do the problem like this, but the distances would be different. All right, so we're looking for this side across from the given angle 45 degrees. I call it A in the work, so you can call this like angle A if that helps. So this is the B squared plus C squared. It's the other two sides. All right, so then we just go ahead and start doing the computations, do the calculator work. To the nearest foot, we get 42 feet. Okay, so there's a couple applications for you to reference. Let's go on to Heron's formula. Okay, they didn't put the condition here, but anytime you're given all three sides of the triangle, then there's an area formula to find this. Okay, this is really kind of the first step in the process. That's why I put number 1 over here, kind of like your success criteria. First step, finds the perimeter divided by 2. They call it an S value in the area formula. Okay, so add them up. Divide by 2, and then once you get that S value, the S value goes in these 4 spots. Okay, so the square root of S minus A, just subtract the 3 sides from S. And then throw in your calculator and you get the area formula. Okay? All right, so let me demonstrate that for 7, then you can try it for 8. Okay, step 1, find the half perimeter. Find S. So find S. All right, so S will be equal to the perimeter, 12 plus 16 plus 19 divided by 2. All right, so you just find that sum. If you're going to throw it on your calculator once, make sure you close the top, because it gives us 47 divided by 2, and we get 23.5 for the half perimeter. Okay, now step 2, once you find S, we're ready for the area. So as it says above, it's the square root of S is first, so 23.5. And then we do S minus A. I mean, you can do the math and just put 11.5 now if you want, or I'll just set it up though, just so you see it happening. So there it is, minus A, minus the B value, then minus the C value. Okay? So it's an easy formula to use, but it's going to be a lot of typing, because when you go in and punch that in, you can once again just put it all under the square root, punch it in just the way you see it, and we get our area. Okay, so you'll practice punching in a moment. I already punched it in. 96, and if they give you units, we'll say feet squared, inches squared, whatever. I'll just create that habit right now. So 96 units squared. Okay, you try for 8. All right, so the half perimeter, we get 11. Okay, so and then here's the setup. Now you go to the calculator, you might want to just do some of this, trust yourself on some mental math. That way you don't have to punch as much in. This is just going to be 2 and 3 and 6, so I'm just taking the square root of the product of those 4 numbers. Okay, so they said the nearest whole number, so 20 units squared is our area. Okay. All right, so that's it for 6.2. 2 days of work, just 1 page front and back. Make sure we're getting comfortable with these 2 different forms today. Make sure we remember that it's only for these 2 conditions. And just remember number 6 too. You might want to use this diagram when you do problem 48 today.